Ta-da! Hey, everybody. Hey, CERN. How are you? Got a quick question for you. I know you're busy, like opening portals to hell and all kinds of crazy things, but I don't know, whatever you're doing. Um, but I appreciate an answer. I don't know. I kind of Googled looking for answers to this question and nothing really came up. So, not that I dug intensively, but didn't find anything. So I thought I'd ask the question directly to you or anyone else out there who could answer the question. That would be great. Boy, this is impressive. Gosh, we're all really impressed down here, I can tell you. Look at this thing, 16.8 miles in circumference, 5.3 miles across. Largest machine ever made by man. I mean, this thing is highly technical, billions of dollars. Boy, I mean, it's impressive. And I was thinking about it. I kind of woke up the other morning thinking about this thing because I went to bed thinking about gyroscopes, laser gyroscopes, fiber optic gyroscopes. And I kind of thought, are we looking at the world's largest gyroscope? We got particles flying in this thing around about the speed of light in a orbital plane, essentially. I guess over here we got kind of France to the west and Switzerland to the east, and this whole thing is going about 700 miles an hour, west to east. And just thinking about precession and this giant thing rotating around the Earth. I was like, because I was looking at, we know how this thing kind of works. We've seen these diagrams. We get the the protons, start getting them going faster and faster, pushing them with magnets. They kind of head out of this guy and they go into this bigger one, which was kind of on that map, the kind of 4 mile ring. We get them pushing faster and faster, approaching the speed of light. Look at them go. Nice. We got particles. We have mass going in an orbital plane. And why is this different than a gyroscope? They go faster and faster. And eventually they go out into the big ring, 16, 17-mile circumference ring. And off they go. Around this big bad boy, which becomes this. Look at her go around. So yeah, that's impressive. So I don't see why, like I said, I was looking around, fiber optic gyroscopes. Basically, use some fiber optics and coils. You shoot two laser beams in each direction around it, and then as the apparatus moves, changes axis, uh, those uh, those beams interfere with each other, and then you use an interferometer to measure the interference, and then spit out, you know, the result, as a gyroscope result as far as how far the apparatus itself has moved, and you'll get a very extremely accurate reading from something like a fiber optic gyroscope. So why is that any different than this thing? We got particles, actual mass going around in a circle. It's almost like a combination of an old style gyroscope that's just steel wheel and something that like a laser or a fiber optic guy who uses photons instead. But now we actually have mass particles being shot around in a big circle, and this thing's moving. Precession. There's this whole thing about gyroscopes and precession versus latitude, and there's a formula which I couldn't really find a calculator for. I did find somebody was talking about the pendulum in Paris goes 11 degrees per hour. I'm still trying to figure out why it isn't just 15 degrees per hour, regardless, because that's how many degrees you're going around in a circle, regardless of the circumference, in 24 hours. But anyways, so 11 degrees per hour, slightly north of here, a couple degrees. So I was like, well, how long do they run these things? And I looked up that question. How long do Large Hadron Collider experiments take? Some guy posted this graph, talking about down here at the bottom. This area here is like 10 to 20 hours, possibly. Once the beam is at full strength, the LHC generates data continuously for somewhere between 10 and 20 hours before the beam intensity is too low and it needs to be dumped. So that's a lot of rotation if they're running that thing for hours and hours. The degrees that thing is shifting is quite a bit. And I know these particles are being directed by magnets. They're not magnets everywhere. They're kind of here and there, but placed in certain spots along that whole guy. But they're pretty symmetrical, top, bottom, side to side. So my question is just, as far as, is this thing basically having to, there's conservation of angular momentum at play. I can't imagine why not. Those particles going in this orbital plane would generate, an angular momentum, and the whole apparatus itself, relative to space and relative to those particles, which are just sort of suspended inside of it, not attached to it or anything. I mean, they're being guided by magnets, but this whole thing's moving. It's tilting. The west side is rising up, and the east side is dipping down, 11 degrees per hour, somewhere in there. And I just wanted to know if you guys accounted for that. I mean, I'm not saying that this thing couldn't work on a spinning ball. I'm sure it could. And you could say, well, this thing, it's moving so slow that the magnets are just, constantly readjusting the path of the particles as it turns. And that's all well and good, but did anyone ask the question? That's what I want to know. When you were designing this thing, building it, all that stuff, was that taken into account? Was precession of this the world's largest man-made machine going around a ball, did you take that into account? That there would be any sort of interference or anything that would have to be accounted for, to re-guide the particles to keep them in line as the whole shebang slowly turns around the world? Stupid question, maybe. Sorry, like I said, I don't want to waste your time, but seems to me like you guys created the world's largest gyroscope, to me, and it would take on those properties, and you would have to account for it somehow, some way, or at least somebody would have to ask the question, even if someone else said, "Yeah, it's no big deal. Forget it. Build it." That's cool if that's your answer, but leave me a comment, send me a message. I appreciate it. Thanks, CERN. I'm sorry to bother you. Get back to wasting everyone's money or doing whatever you're doing. Peace.